Greetings, fellow mathematicians! We're going to take a look at a really important question, finding the antiderivative for natural log of x. And as it turns out, this requires integration by parts, which is why you haven't addressed it prior to now. Now, let's think about our possible choices here and keeping in mind all of your tips. Now, there's not a lot of choices for u and dv. Let's just suppose we tried dv as natural log of x. All right, so let's suppose we tried that. The problem here, we don't yet know an antiderivative for natural log of x. So with this choice, you would have to integrate that to get v. And that is circular. We don't know an antiderivative for natural log of x, so we wouldn't be able to use this choice, because we have to know an antiderivative for natural log of x to get v. So let's not choose dv as natural log of x. Let's choose u as natural log of x. All right, and that means everything else, which is just dx, or 1 dx, will be our choice for dv. All right, now here the calculations are really simple. Don't forget your derivative of natural log of x. Du here comes out to 1 over x dx. All right, and if you integrate 1, or your antiderivative for 1, that's x. So v is x. And always check just by doing a quick derivative. X does differentiate to 1, so there we go. We just have to plug all this into our integration by parts formula. We get u times v. Let me mention a tip for notation. Don't write this as natural log of x times x. In other words, don't write that, because some students might confuse this as that x, that factor, as multiplying the x inside of natural log. Now, if you're comfortable and understand notation, you won't make that mistake, but this is not the same thing as natural log of x squared. So just be careful. If you are going to write that, it might be better to write that with a set of function parentheses around the x inside the natural log function. That way you're not tempted to multiply there. So one way to get around that, let me just switch and write it as x times natural log of x. All right, and then we get now the integral of v du. And notice when I multiply x by 1 over x, that cancels to 1. So we get the integral here of 1 dx. And that is really simple. That's just going to integrate to x. And we are done. Just carry your work down, and what we find here is the antiderivative, or integral, of natural log of x equals x natural log of x minus x. And of course, don't forget your plus c. And that's how we find an antiderivative for natural log of x. It's a very straightforward integration by parts, choosing u as natural log of x and dv as dx. And that's actually an important choice, realizing that you can pick dv as just dx. And that's going to happen for a few problems, typically anytime you're dealing with inverse functions. Natural log of x, that's the inverse of the exponential function e to the x. Now, for those of you continuing through other mathematics, science, and engineering courses, this is just a great antiderivative to basically memorize and lock away from here, since it pops up pretty frequently. So think of this as now another basic antiderivative to add to the ones you already know. Hope you enjoyed this short video. I hope you're learning a lot. If you are, support the channel, like and subscribe.